Welcome to the deep dive. Today, we're jumping straight into probably the biggest strategic question facing businesses in the generative AI era.
Right, that fundamental choice.
Yeah.
Do you build your own AI capabilities or do you buy existing solutions?
Exactly. And, as large language models shift from being these sort of experimental things to the absolute core of innovation, well, every organization, big or small, is hitting this fork in the road.
It really is a critical decision, and it goes way beyond just picking some software off a shelf. It's about your strategy for expertise, for cost, for speed.
Talent, competitive edge, it touches everything.
It does. And it's about understanding those trade-offs, especially now with generative AI raising the stakes.
Absolutely. So for you, our listener, if you need to get your head around the real-world impact of this build or buy choice, quickly but thoroughly, this deep dive is your shortcut.
We're going to dissect the expert thinking on this, looking at that lean, fast approach of buying third-party tools.
Versus the big, sometimes necessary investment in building your own custom AI in-house.
So fundamentally, we're looking at two main paths, two poles of the strategy, if you will.
Okay, let's define those.
First, there's buy. This mostly means, licensing ready-made AI apps, maybe using foundation models through APIs. Think of it like outsourcing the heavy AI lifting.
Got it.
Uh,
Buying access to someone else's powerful model or tool.
Right. And the second pole is build. Now, we should be clear here.
Yeah.
For almost every company, build doesn't mean creating a giant foundational model like Google or OpenAI. That's a whole different league.
Right, not building GPT-5 from scratch in your basement.
Exactly. For most businesses, build means investing in an internal team, ML engineers, data scientists, to maybe fine-tune existing open source models with their own data.
Or creating really unique, deeply integrated AI applications tailored specifically to their business, things competitors can't easily copy.
Precisely. But here's maybe the key takeaway before we even get into the weeds. For the vast majority, the real strategic puzzle isn't picking just one. It's figuring out the right mix and, crucially, the right sequence.
So it's not purely binary. It's about timing and combination.
Exactly. Do you go for speed now with off-the-shelf tools, knowing you might build something more custom later? Or do you invest up front for that unique edge? That's the nuance we need to explore.
Okay, great framing. So let's start by unpacking that first approach, the buy strategy, the lean, nimble way, leveraging third-party solutions. What's the big draw?
Speed. Without a doubt, the number one advantage is sheer velocity, fast time to market.
Getting something working quickly.
Dramatically quicker.
Right.
Implementing an existing solution, you could be talking weeks to get something valuable deployed. Compare that to building from scratch, which is often months, if not years.
Right, you bypass those long internal development cycles.
You do. You can get quick wins, show value almost immediately.
Okay, let's make that concrete. The Morgan Stanley example is often cited here, isn't it, with their wealth managers?
It's a perfect illustration. They had, 16,000 financial advisors?
Yeah, a huge number.
And these advisors needed instant conversational access to this massive, complex library of internal research, market analysis, investment strategies, compliance docs, you name it.
The information was there, but getting to it was slow, fragmented.
Exactly. So Morgan Stanley realized, look, speed is paramount here. They didn't decide to spend, 3 years and a fortune trying to build their own foundational model to rival the big players.
Oh, they partnered.
They partnered strategically with OpenAI. They took GPT-4, fine-tuned it just enough with their proprietary documents so the answers were highly relevant to their advisors' needs, and rolled out an assistant.
And the result?
Instant productivity gains. 16,000 advisors suddenly able to query all that internal knowledge instantly. That kind of speed, that scale of deployment, an internal build just couldn't match that time frame.
It highlights that focus on the business outcome, getting the tool to the advisors over maybe owning the underlying tech stack completely.
Precisely. And that speed connects directly to the second big advantage, cost, or at least upfront cost.
Okay, tell me about that.
Buying AI as a service, usually subscription or usage-based fees, means a much lower initial financial hit. You avoid that massive capital expenditure.
The CapEx for hiring a big ML team, buying all those expensive GPUs, setting up the whole development infrastructure.
Right. You sidestep a lot of that initial heavy lift. It shifts the cost profile more towards operational expenditure, OpEx.
Which generally makes budgeting a bit easier, more predictable.
Often, yes. Your costs tend to scale more directly with usage. Now, don't get me wrong, those API fees can definitely add up, especially at massive scale. We've all heard stories.
Oh, yeah.
But managing those ongoing usage costs is usually less daunting than navigating the huge, uncertain capital outlay
Sure.
and the very real risk of cost overruns on a complex internal build.
Okay, so speed, lower upfront cost.
Yeah.
What else does buy offer?
Reduced talent dependency. This is huge.
Ah, the war for AI talent.
It's fierce and expensive. When you buy, you're essentially outsourcing the incredibly difficult job of finding, hiring, and retaining those top-tier, very expensive machine learning experts.
The vendor handles the really complex stuff, the core model development, the massive training runs, keeping the infrastructure running, the constant tuning.
They do, which means your internal team can be much leaner. They can focus on the crucial parts: integration, configuration, making sure the tool actually fits your business workflows.
So you need skilled integration people, maybe business analysts, but not necessarily a whole platoon of AI PhDs.
Exactly, which, given the talent market, is a massive operational relief for many companies.
Makes sense. Is there anything else on the pro side for buying?
Yeah, one more, and it's often overlooked but really valuable:
Mm.
continuous upgrades.
Meme.
When you license a solution from a good provider, you automatically benefit from their ongoing R&D. They're constantly improving their models, fixing bugs, adding new capabilities based on the latest research.
So you're kind of riding the wave of the whole AI industry's progress without funding your own massive research division.
You got it. It's like getting continuous, state-of-the-art improvements to the core engine, essentially for free as part of your license or subscription.
Okay, that paints a pretty rosy picture. Speed, lower initial cost, less talent headache, free upgrades. It sounds almost too good to be true.
Well, like any strategy, it comes with trade-offs, significant ones.
All right, let's flip the coin. What are the downsides, the cons and cautions of the buy approach?
The big one is limited customization and differentiation. That's the core vulnerability.
Because these off-the-shelf tools are built for everyone.
Exactly. They're designed for broad market appeal. They might not fit your really specific niche requirements perfectly. You often lack the deep flexibility to tailor the AI's behavior precisely to your unique, maybe proprietary workflows.
And if you and your main competitors are all using the same underlying third-party model,
Then where's your competitive edge coming from? You end up competing mainly on how well you integrate it, not on having a truly unique AI capability. It can limit differentiation.
that makes sense. And that lack of control leads to another risk, right? Vendor dependency.
Absolutely. Strategic lock-in. It's a classic IT risk, amplified with AI.
Because you're relying on this external provider for something potentially core to your operations.
Yes. And you give up control over that core tech stack. What happens if your vendor suddenly changes their pricing model drastically, or changes their product roadmap in a way that doesn't suit you?
Or worse, what if they have a major outage or, heaven forbid, go out of business?
Your operations could be significantly disrupted. That dependency is a real strategic risk you have to weigh.
Okay, limited customization, vendor lock-in. What about data? That seems like a huge concern, especially with sensitive information.
It's arguably the most critical concern for many, especially in regulated industries: data security and compliance.
The big question: can you safely send your sensitive data, patient records, financial data, proprietary designs, to a third-party AI service, even if they promise it's secure?
For many organizations, particularly in healthcare, finance, government, the answer is often a hard no, or at least requires extremely rigorous vetting and specific contractual guarantees. Off-the-shelf models might not meet strict industry regulations like HIPAA or GDPR out of the box.
That Samsung incident really brought this home, didn't it?
It was a stark reminder. Employees inadvertently pasted sensitive internal source code into a public cloud AI tool.
And that code potentially became part of the vendor's training data or logs.
Okay.
A major leak.
A catastrophic leak, demonstrating the very real risk when internal secrets interact with external generalized models. You absolutely have to consider that pathway before sending any sensitive data out.
Okay, so data security is paramount. Any other major cautions on the buy side?
Yes, integration and performance caveats. While vendors often tout ease of use,
It's never quite plug and play, is it?
rarely, especially in complex enterprise environments. Significant technical work is often still needed to properly integrate these third-party tools into your existing legacy systems, your databases, your workflows.
And companies trip up here.
They do. One data point we found suggested that around 26% of failed AI pilot projects We're blamed on underestimating these implementation and integration hurdles. It takes time, it takes resources, it takes expertise.
So it's not zero effort internally, even when buying.
Definitely not. And you also give up control over performance characteristics. Things like latency, how quickly the model responds.
Right, that depends entirely on the vendor's server load at that moment.
Exactly. If their service is slow, or if they impose rate limits on your usage, your user experience suffers, and there's often little you can do about it directly. You trade that granular performance control for the convenience of the service. Sometimes that trade-off is just too costly for critical applications.
Okay, so we've established the buy path. Fast, potentially cheaper upfront, less talent stress, but risky on customization, lock-in, data security, and performance control.
A fair summary.
So what if those risks are unacceptable? What if you need absolute control, deep customization, maybe ironclad data security? That brings us to the other side, the build strategy.
Right, the robust in-house approach, building your own internal AI capabilities.
If you're willing and able to make the investment, what are the big advantages here?
The upsides can be profound. It starts with deep customization and alignment.
Going beyond just fine-tuning.
Potentially, yes. Or just
And
having complete control over that fine-tuning. Internal development means the AI can be designed exactly around your unique business requirements. You control everything.
like the training data, the model architecture, if you're tuning an open source one, the APIs, the user interface, all of it.
All of it. You can tailor it precisely. And crucially, you can train it on your proprietary data sets, the internal knowledge, the customer interaction data that no competitor possesses.
That institutional knowledge that makes your company unique.
Exactly. That level of specific alignment with your industry nuances, your internal processes, it creates bespoke functionality that's often impossible to replicate with an off-the-shelf tool.
And that ties directly into the data security point, right?
Absolutely. For many, this is the non-negotiable benefit of building maximum data security and compliance.
Because everything stays within your walls, or at least within your controlled environment.
Correct. When you build internally, sensitive data stays within your organization's firewall, or perhaps a dedicated private cloud instance that you control completely. You dictate precisely how data is stored, processed, accessed, logged.
Which allows you to implement really granular security controls, audit trails, compliance measures right from the start.
From the ground up. So, for those handling highly sensitive healthcare records, critical government intelligence, confidential financial transactions, building internally or using a very secure private deployment is often the only path that truly satisfies regulatory and security mandates.
Okay, customization, security. What about the competitive angle?
This is where building can really shine, creating genuine competitive advantage and unique intellectual property.
Because you own the solution.
Yes. If AI is truly core to your product or your main value proposition to customers, then owning that AI solution creates a strategic moat. It's know-how, it's technology that competitors can't just go out and license from the same vendor you're using.
This brings us back to Bloomberg, doesn't it? Their Bloomberg GPT.
A prime example of a strategic build. Bloomberg's entire business is financial data and sophisticated analytics.
So a generic language model, however good, just wouldn't cut it for their specific needs.
It wouldn't have that deep, nuanced understanding of financial jargon, market dynamics, the connections between obscure economic indicators that their clients rely on.
So they went all in.
They invested massively, built Bloomberg GPT, a 50 billion parameter model, trained specifically on their decades of curated, high-quality financial data, a huge undertaking.
Millions in compute costs for training alone, I imagine.
Easily. But the result is a model with domain excellence in finance that generic models simply can't replicate. That proprietary capability becomes a core part of their value proposition, a strategic asset.
A real competitive moat, as you said.
Definitely. And related to that control, internal teams also gain maximum control over performance and integration.
How so?
They can architect the solution precisely for their needs, maybe minimize latency by hosting models physically close to where the data is processed or on premises. They can relentlessly fine-tune models to maximize accuracy on their specific types of data or tasks.
They're not subject to a vendor's SLA or unpredictable network lag.
Exactly. They are masters of their own performance destiny, which can be critical for real-time or near real-time applications.
Okay. And is there a long-term cost argument for building, too? It seems counterintuitive given the huge upfront investment.
There can be, yes, especially at massive scale, while that initial sticker shock is high.
Astronomical, sometimes.
Right. But if you project usage out over several years, and you anticipate, say, billions of internal queries or transactions running through this AI,
Then the cumulative cost of paying per query API fees to a third party could eventually exceed the amortized cost of your internal build.
potentially yes. For very high volume, long-term use cases, owning the technology can eventually become more cost-effective than perpetually renting it. You have to do the math carefully on the total cost of ownership, but for some, building offers long-term cost efficiency at scale.
Okay, that's a compelling case for ownership. Deep customization, ironclad security, unique IP, performance control, and maybe even long-term cost savings, but it sounds hard and risky.
It absolutely is. The
Mm.
build path is definitely not for the faint of heart. The challenges are significant.
Let's talk about those obstacles. What's the biggest hurdle?
Cost. High upfront talent and infrastructure costs are the major deterrent for most.
We're back to the talent war and the expensive hardware.
Exactly. Building requires substantial capital right out of the gate. You need to hire those specialized, high-salary roles, ML research scientists, MLOps engineers, data architects. These people are in high demand.
And the compute power.
Punishingly expensive.
Yeah.
We're talking about potentially large clusters of powerful GPUs for training and then serving these models efficiently. The cost for hardware and cloud compute can run into the millions very quickly, far exceeding buying software licenses.
So you need not just a big budget, but real executive commitment, viewing this as core infrastructure, not just an IT project.
Absolutely. It's a strategic infrastructure investment. And with that investment comes another major challenge.
Longer time to market.
Much longer. Development cycles for genuinely novel or deeply integrated AI systems are measured in months, often quarters, sometimes even years.
Which means you might miss the boat in a fast-moving market.
That's the risk. If speed is absolutely critical to capture a fleeting opportunity, building in-house is often simply too slow. It's an investment in long-term capability, but it requires patience and a tolerance for delayed ROI that not every business has.
Okay, so it's expensive and slow to get started. What about once it's built? Is it smooth sailing then?
Not necessarily, because then you face the ongoing maintenance and support burden.
You built it, you own it, all of it.
All of it. The good, the bad, the bugs. This isn't a one-time build. It requires a dedicated team, often called MLOps, machine learning operations. Their job is continuous support, updates, monitoring, improvements.
And it's not just fixing bugs, right? There's this concept of model drift.
That's a key technical challenge. Model drift is when the model's accuracy degrades over time,
Why does that happen?
because the real-world data it encounters starts to differ from the data it was originally trained on. Think about economic models trained before the pandemic suddenly facing post-pandemic data patterns. The world changes.
So the model gets out of sync with reality.
Exactly. And combating drift requires continuous monitoring, retraining the model with fresh data, potentially tweaking the architecture. It's a significant, costly, ongoing commitment to keep your bespoke model performing well and staying competitive.
Okay, high cost, slow start, ongoing maintenance. What's the final big risk?
Performance risk. The risk that, after all that investment and effort, your custom-built solution simply doesn't perform as well as the leading external models.
Ouch. All that work, and it's still subpar.
It's a real possibility. Building state-of-the-art AI is incredibly complex. Frankly, without truly world-class internal expertise and significant resources, there's a measurable risk your custom solution might underperform the models coming out of places like Google, Anthropic, or OpenAI, who have thousands of researchers dedicated to this.
Is there data to back that up?
There is. One survey we looked at was quite candid. 61% of companies reported experiencing accuracy issues with their in-house generative AI solutions.
61%, that's high.
It is. And only about 17% rated their custom solutions performance as truly excellent. It shows that while the promise of bespoke AI is incredibly appealing, the execution risk is very real. Achieving that world-class quality internally is a major, major hurdle for most organizations.
Wow. Okay, so we have these two distinct paths. Buy,
Yeah.
fast, cheaper start, less control, potential lock-in, build, slow, expensive, total control, but high execution risk and maintenance burden.
That's the core tension.
So the crucial question for any leader facing this is, how do you actually weigh these factors? How do you make the right call for your specific situation? Let's dig into those key strategic factors.
Okay, let's unpack this. The first thing, maybe the most fundamental, is what I'd call the DNA check.
DNA check.
Yeah. How central, how fundamental is this specific AI capability to your company's core value proposition? Is AI the thing you sell or a key differentiator?
Like Bloomberg with its financial analysis, AI is their product, essentially.
Exactly. In cases like that, where AI is deeply embedded in your core offering, or as your primary source of competitive advantage, leaning heavily towards building, or at least owning critical components, makes strong strategic sense.
But what if it's not? What if AI is more of a supporting function?
Right. If AI is more of a utility songs, maybe automating internal processes like invoice
Yeah.
processing, enhancing customer service responses, providing IT support functions that improve efficiency but aren't the core product.
Then buying an off-the-shelf solution is probably good enough.
Almost certainly sufficient and likely much more practical. The key is alignment. Don't launch a massive, expensive, risky internal build if AI isn't truly part of your organizational DNA or leveraging unique strengths you already possess, like proprietary data.
Makes sense. Align the effort with the strategic importance. Okay, what's next after the DNA check?
Cost, but not just the sticker price. Leaders have to get granular and look at the total cost of ownership, the TCO.
Right, comparing the long-term view, not just the initial outlay.
Precisely. You have to map those heavy upfront development costs, the talent acquisition, the infrastructure for the build path.
Against the ongoing subscription fees, the per transaction or per token usage costs for the buy path, potentially over 3 to 5 years.
And when calculating that TCO for building, it's crucial not to overlook the hidden costs.
Such as, what do executives often miss?
Oh, plenty. The cost of getting your data ready, cleaning it, labeling it, setting up governance pipelines, that can be a massive project in itself before you even start training.
Right, data prep is huge.
Huge. Then there are the specialized MLOps tools needed to manage the model lifecycle. Those often have significant licensing fees themselves. And crucially, the amortized costs of that expensive GPU infrastructure. GPUs have a relatively short useful lifespan before they're obsolete, so that capital investment needs to be properly accounted for in the TCO.
So these hidden costs can really inflate the true cost of building.
They often push the TCO for build much higher than initial optimistic estimates. You need a realistic financial model.
Okay, so cost is critical. But here's something fascinating from the research on what actually drives adoption decisions.
Yeah.
We talk about costs constantly, right? But one survey of enterprise AI adopters found that only 1%, just one, cited price as their top concern when picking a solution.
Only 1%. That's striking. What was most important then?
Measurable value, that was number one, cited by 30% of adopters.
Yeah.
And fitting the industry context was second at 26%. Price was way down the list.
Okay, that's a really critical insight. What does it tell us?
It confirms that if the AI solution delivers significant, measurable return on investment, high ROI companies are willing to pay for it, whether it's built or bought.
So the focus shouldn't just be on minimizing cost, but on maximizing value. Defining that value clearly upfront is key.
Exactly. Is this tool going to reduce customer churn by X%, increase sales conversion rates by Y%, cut operational overhead by Z%? If you can quantify that value, and it's high enough, the investment build or buy becomes much easier to justify.
The strategic goal is ROI, not just cost savings. Makes perfect sense.
But delivering that ROI, especially if you choose to build, hinges entirely on having the right people. Which brings us back to the talent audit.
The inescapable talent question. Look, if your company simply cannot realistically attract, hire, and retain those top-tier ML engineers and data scientists,
Then launching a major internal build is probably a fantasy.
it's a high-risk fantasy, yes. It's
Yeah.
likely to stall, run over budget, or worse, result in a subpar product that doesn't deliver the promised value.
So the strategy has to be grounded in the reality of your current team's capabilities.
Absolutely. Let's make it tactical. If your existing IT team is strong in general software development, maybe Python, cloud integration, API management, then your strategy should probably lean towards buying and integrating best-of-breed third-party tools. Play to those integration strengths.
But if you happen to have, or can realistically acquire, deep expertise in more specialized areas, maybe natural language processing, computer vision, advanced statistics, distributed systems,
Then building becomes a more viable path because you have the human capital to actually manage that complexity and potentially create something truly unique. The strategy must align with your talent reality.
okay, DNA check, TCO, and value focus, talent audit. What's the final major factor to weigh?
The non-negotiables: data privacy, security, and looking ahead, flexibility.
Compliance often being the hard line in the sand.
Often, yes. For those sectors with really strict data regulations, healthcare with HIPAA, finance with various regulations, government, anything handling PII under GDPR. An internal, private, secure solution might simply be the only legally compliant route. Public cloud AI services might be off the table for certain core data.
But even if you are allowed to use external services, due diligence is critical.
Intense due diligence. You have to scrutinize the vendor's compliance certifications. Do they have SOC 2 Type 2, ISO 27001? Are they GDPR compliant? You need to confirm data residency guarantees. Where will your data actually live?
And many vendors are responding to this, aren't they? Offering private cloud options.
Yes, exactly. Many large enterprise vendors now offer private, dedicated instances or deployments within a customer's own virtual private cloud. This creates a kind of bi-hybrid model that can meet stricter security and compliance needs while still leveraging the vendor's core technology.
Okay, so security is table stakes. What about flexibility? Why is that important?
Thinking about the future, the AI landscape is moving incredibly fast. The best model today might not be the best model in 6 months or a year.
So you need the ability to adapt.
Ideally, yes. Do you need the strategic agility to easily swap out the underlying AI engine if something better comes along? Buying into a fully proprietary closed-source platform can create significant vendor lock-in, making it hard to switch.
Whereas a well-designed internal system, maybe using open source components.
Or even a hybrid system where you control the data and orchestration layer allows for greater flexibility. You could potentially substitute different open source foundation models or switch between different external API providers more easily as the market evolves and performance characteristics change.
So maintaining that ability to adapt might require owning at least parts of the stack, like the data handling or the interface layer.
That's often the thinking behind a well-architected hybrid approach. It gives you options down the road.
Okay, we've laid out the build versus buy polls, the pros and cons, the key decision factors. But you hinted earlier that the reality on the ground isn't always strictly one or the other.
Exactly. For most organizations today, the answer isn't purely build or buy. The answer is increasingly both. We're firmly in the era of the hybrid strategy.
A middle ground.
It's become the dominant approach because it cleverly allows organizations to capture some of the speed and cost benefits of buying while still retaining essential control, customization, and security where it matters most.
How does that work in practice? What does a hybrid model look like?
Typically, companies start with existing foundation models, either licensed from a vendor or using powerful open source ones. But then, crucially, they build custom components and orchestration layers on top of those foundation models.
Okay, building on top of something existing. And there's a key technology enabling this, isn't there? You mentioned it earlier, RAG.
Yes, Retrieval Augmented Generation, or RAG. It's become a cornerstone of the practical hybrid strategy. We should probably unpack that a bit more.
Please do. What exactly is R and why is it so important here?
Okay, think of a big, powerful foundation model like GPT-4 or Claude 3 as like a brilliant, incredibly knowledgeable librarian. It's read basically everything on the public internet, history, literature, science.
Knows a massive amount about the world in general.
Right. But now, imagine that financial advisor at Morgan Stanley again. They ask the AI assistant, what's the key change in our internal compliance handbook from last year regarding derivatives trading?
That super smart public librarian model has no idea, right? It hasn't read Morgan Stanley's internal confidential handbook.
Exactly. And Morgan Stanley definitely doesn't want to just upload that entire confidential handbook into the public model's training data. Massive security risk.
Okay, so how does RAG solve this?
RAG acts like a smart, secure system between the user and the big librarian model. Here's the flow. First, you take your internal proprietary documents, the handbook, research reports, client FAQs, whatever, and you create a secure, searchable index of that knowledge within your own controlled environment.
Okay, so the knowledge stays in-house.
Stays in-house. Now, when the user asks their question, what changed in the handbook, the RAG system first searches your secure internal index to find the most relevant snippets of text from the handbook that likely contain the answer. This is the retrieval part.
Got it. It finds the relevant paragraphs internally.
Then, the RAG system takes the user's original question plus those retrieved snippets of verified internal information and bundles them together. It sends that bundle to the big, powerful external LLM, the librarian.
Ah, so it gives the LLM the specific context it needs right alongside the question.
Precisely. It essentially says, okay, Mr. Smart Librarian, using only these trusted documents I'm handing you right now, please answer this user question. This is the augmented generation part.
So the LLM generates the answer based only on the secure, relevant information provided, not its general world knowledge, and critically, not by accessing the secure database directly.
Correct. The LLM uses its powerful reasoning and language capabilities to synthesize an accurate, relevant answer from the trusted internal snippets. The sensitive data itself never has to leave your secure environment to be processed or trained on by the external model.
That's clever. It leverages the power of the big models without compromising the security of the proprietary data.
Exactly. It elegantly solves one of the biggest hurdles of just using external models directly for enterprise tasks involving sensitive information. And it's the core of most successful hybrid strategies today.
And this hybrid approach, using things like RAG, gives companies more flexibility too.
It does. It provides strategic agility. You can route general knowledge questions maybe to a cheap, fast external model, but questions requiring proprietary data go through your secure RG system. You could potentially swap out the underlying LLM used by their RG system if a better one comes along without rebuilding everything. It helps avoid that single vendor lock-in.
So you get speed from the external model's capabilities, but control and security from your internal retrieval and orchestration layer.
That's the goal. The best of both worlds, tailored to the specific task.
And is this hybrid approach just theoretical, or are we seeing it widely adopted?
We're seeing a clear shift in the market data. It's fascinating. Recent surveys show that now something like 47% of enterprise Gen AI solutions are either developed fully in-house or involve these heavily customized hybrid components.
Okay, 47% built hybrid. What's the rest?
About 53% are primarily sourced directly from vendors, like off-the-shelf SaaS tools or direct API usage.
So it's roughly half and half now. That is a shift.
It's a significant shift because maybe a year or so prior, vendors probably dominated with closer to 70 or 80% market share for initial deployments.
What does that shift tell you?
It tells me companies are rapidly moving up the learning curve. They're gaining the confidence and the technical know-how to build these custom components. The RAG systems, the specialized fine-tuning pipelines, the unique integrations where it delivers real differentiation.
So they're still leveraging the power of external models, but they're increasingly building the value-add layers themselves.
Exactly. They're getting smarter about using high-quality external offerings for the commodity parts, like basic language understanding, but investing their internal effort on the unique parts that matter most to their business.
Okay, let's bring this back to our case studies to see this in action. Morgan Stanley, Bloomberg, JP Morgan Chase. How do they illustrate these different strategic choices?
Right, revisiting them highlights how corporate culture and strategic priorities drive the decision. Morgan Stanley, as we discussed, is the classic buy-partner win, at least initially.
Their priority was speed above all else.
Overwhelmingly velocity.
Right.
Get a powerful tool into the hands of 16,000 advisors, ASAP, to unlock productivity. They accepted the vendor dependency on OpenAI and Microsoft Azure because speed was the bottleneck they absolutely had to break.
Okay, so speed drove the buy decision there. Then you have Bloomberg.
The strategic build win. Their priority was completely different. Deep competitive differentiation and owning the intellectual property based on their unique financial data.
So building Bloomberg GPT, despite the massive cost and time, was essential for their strategy.
Essential. It created an AI asset intrinsically tuned to finance, something competitors simply cannot license. It's a long-term strategic moat built for decades, justifying the immense investment.
Two giants, different priorities, different paths. Now, what about JP Morgan Chase? How did they approach it compared to Morgan Stanley?
JPMC provides a fascinating contrast, especially to Morgan Stanley. While MS partnered externally, JP Morgan Chase went the internal route. They developed their own suite of internal LLMs, reportedly called Index GPT.
So they chose to build. Similar to Bloomberg in principle, but maybe for different reasons.
Similar in choosing build, yes. But the driver seems rooted more in their deep-seated organizational culture. JPMC has a long history of building its core technology internally. And for them, prioritizing absolute ownership and security of their incredibly sensitive financial data was paramount.
So the cost and time of internal development was seen as a necessary price for maintaining total control, auditability, and data sovereignty.
That appears to be the calculation. It contrasts sharply with Morgan Stanley's willingness to partner externally to gain speed. It really underscores that there's no single right answer, even within the same highly regulated industry.
Two titans of finance facing the same technology wave chose fundamentally opposite initial strategies based on their culture, risk appetite, and perceived urgency.
Exactly. It proves the decision is deeply contextual.
Okay, so whether a company leans towards build, buy, or, as seems most common now, embraces a sophisticated hybrid model, are there common mistakes? universal pitfalls that leaders should actively try to avoid, regardless of the path chosen.
Oh, absolutely. Despite the path, organizations often stumble in similar ways. We can probably group the biggest dangers into three main areas:
Okay, what's the first danger zone?
neglecting governance and risk management from the outset. This isn't just a technical checkbox, it's fundamental.
What kind of risks are we talking about?
Things like managing the risk of biased outputs from the AI, dealing with the infamous hallucinations where the model confidently makes things up.
Which can be incredibly damaging if acted upon.
Absolutely. And ensuring compliance with regulations, managing data privacy, establishing clear lines of accountability for the AI's decisions. These things need proactive governance, often through a dedicated cross-functional AI ethics or risk committee. It can't be an afterthought.
Okay, so robust governance is crucial. What's the second common pitfall?
Treating AI adoption purely as a technology implementation project.
Focusing only on the tech and forgetting the people and process.
Precisely. In reality, successful AI adoption requires significant organizational change management. You need to train users effectively, redesign workflows to actually leverage the AI's capabilities, build trust in the system.
We've all seen cool tech fail because people didn't know how or didn't want to use it.
Exactly. Companies fall in love with the shiny new AI tool and forget the ultimate goal is business outcome. If the people aren't brought along, if the processes aren't adapted, the investment will likely fail to deliver value, no matter how brilliant the underlying tech is.
Okay, governance, change management.
What's the third danger?
Being overly siloed in the development or deployment.
Meaning.
Sometimes a specific department or team will invest heavily, maybe build a technically fantastic AI tool, but it ultimately fails to gain traction.
Why would that happen? Maybe because it doesn't integrate effectively with the other critical systems or workflows across the organization. Or, perhaps more critically, it lacked broad executive buy-in from the start, so there's no top-down push to drive adoption and ensure it aligns with overall company strategy.
So you need that holistic view, connecting the AI initiative to the bigger picture.
You absolutely do. You need alignment between the technology, the business processes, the people using it, and the executive strategy to ensure the AI delivers sustained, enterprise-wide value, not just a niche tool in a corner.
Governance, change management, avoiding silos. Got it. This has been an incredibly insightful deep dive into a really complex but vital strategic landscape. Let's try to synthesize the key takeaways for everyone listening.
Okay, so the bottom line seems to be that the optimal strategy, build, buy, or hybrid, really has to align tightly with your specific context.
Your urgency, how sensitive your data is, your budget realities, and maybe most importantly, how truly strategic this AI capability is to your core business.
Right. And the emerging best practice, or at least the common pattern we're seeing, suggests many are finding success by starting pragmatically.
How so?
Using third-party tools, perhaps in pilot projects or for less critical functions, to get quick wins, gain the crucial institutional knowledge about how to actually deploy and manage AI in their environment.
Learn by doing, essentially.
Learn by doing with lower initial risk. Then, armed with that experience, they can pivot to investing in building custom internal solutions only for those functions that are truly differentiating, or handle highly proprietary data, or require maximum security and customization.
And often using that hybrid oxide or architecture we discussed to smartly connect the external capabilities with their internal secure data.
Exactly. It's a phased, pragmatic approach.
So the ultimate goal here isn't about ideological purity being a builder or a buyer. It's about results.
It's entirely about delivering massive, measurable business value with AI. That's the end game.
And the organizations that succeed will be the ones who masterfully blend the agility and cutting-edge tech available from the external market.
With the specificity, control, and security they can achieve through targeted, smart, in-house development and integration. It's about that effective marriage of the two worlds.
A powerful synthesis. Before we wrap up, any final provocative thought for our listeners to chew on?
Okay, here's where it might get really interesting looking ahead. We see the cost of accessing incredibly powerful foundation models continuing to drop, right? They're rapidly becoming almost like a commodity, like compute power or storage.
Right, the underlying engines are getting cheaper and more accessible.
So if that trend continues,
Mm.
will the real sustainable competitive advantage in the future lie less in actually building the core foundation model itself, because maybe only a few mega players will do that effectively at scale?
And more in how uniquely and effectively you build that layer on top.
Exactly. More in how uniquely you construct that sophisticated orchestration layer, the custom RG systems retrieving your specific knowledge, the fine-tuned MLO's pipelines managing your specific workflows, the proprietary knowledge graphs connecting your internal data in novel ways, that layer that intelligently integrates both internal assets and external commodity AI tools.
So the secret sauce isn't the base model, but the custom integration and orchestration.
That specific, customized orchestration tailored precisely to your business data and processes that might just be the next trillion-dollar competitive battlefield. Something for you all to mull over.